Hi there. I'm Hao. It is just another me, a random code problem. So let's begin. So you're given an n by n grid where each cell can have one or three values, 0, 1, and 2. 0 is an empty cell, right? 1 is the fresh orange, this one, and then 2 is a rotten orange. Okay. So every minute, any fresh orange that is four directionally adjacent to a rotten orange becomes rotten. So it is left, right, top and bottom, right? So if a fresh orange is placed next to the rotten orange, then 1 minute later, it will become rotten as well. And we want to return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. Okay. Um, so when we find the minimum of something, right, in the I'm thinking about breadth first search. So we can do this using a queue. We can use this using a queue, right? So we can start from let's say we have one dot is 2, 1, 1, and then 1, 1, 0, and then 0, 1, right? We can start with 2, right? And we look at the neighbors, right? We can keep track of the minutes. So each time we go down a level in the recursion, right? We want to keep track of the number of minutes. Um, we uh, we have elapsed, right? And we also keep track of the total oranges, right? We can have the first iteration to calculate the total orange, and as we add, this node into our um, queue, right? We can just decrement the orange. And we can return when the orange is 0, right? So if when we exit the while loop, if we still have oranges, which means it is impossible to do it, so we will return -1, right? Right, impossible mean like for example, you have like cell like this. Uh, the fresh orange here will never be reached from the number 2, right? From the rotten orange. So that is one of the case, right? And we can keep going, right? Look at this and this, right? This 2, right? We keep decrement our orange, right? We can look at this one, right? If it is a 0, we don't, if it's an empty cell, we just ignore, right? So on and so forth, right? So it is 3, right? It is 4, right? So it's like around uh, uh, 4 levels, so 4 minutes, right? Uh, for all the orange to be run, right? So let's look at another example here. We have like 2, 1, 1, 1, 1, 0, and 0, 1. Let's say this is also 2, right? So like you can think about this as like we traversing like top down, right, from the tree. So let's say it is a route, right? We look at the 2, right? We start from because we always start from the rotten orange and see how far we can go, right? While keeping track of the number of fresh orange remaining, right? So we start from here, right? We look at the neighbors. It is an empty cell, so we ignore. Look at 1. Here we look at 1, 1, right? So what is this? It is 1, right? 1. So it takes 1 minute. It takes 1 minute to let me change the color here. Um, yellow. Okay, so it takes 1 minute to so the red here, right? It's like one minute, 1 minute to rotten those 3 uh oranges, right? Yellow here, yellow is 0 minutes, right? Okay, so the next one we able 0, 1, just take two neighbors, so it is 2 minutes, right? Yes. So each time we iterate, we only have to start from the rotten orange, and we need to finish iterate. We have to finish looking at all the neighbors of the rotten orange, right? That is why the 3 red here is 1 level. So to get visualize it, we can do it like this, like the one. So this is 0, 1, right? Which is 0, 1. It is 1, 0, right? 1, 0. This is 2, 1, right? So on and so forth, right? So these three are 1 level. So this would work. However, it would be a little bit space consuming if we need our queue, right? So there's another way to do it that I think is a little bit better. So let's say we have 2, 1, 1, and then 1, 1, 0, 0, 1, 2, right? So actually we can have a time here, a timestamp. We can start from 2. But the reason we start from 2 is because the number 0 to 2 is already being used, right? So we cannot use those numbers, and we can return the time rate -2 at the end because we start from 2. So that we can use like the number that haven't been used like here, right? So if you look at the constraints right here, rid of I and j will always be 0, either 0, 1, or 2, right? So if we start from 2, and we can so we can iterate through the whole matrix and look for the rotten orange. We will start from the rotten orange, right? Number 2 here. So we found 2 here and 2 here, right? Okay. When we found 2, what do? We look at the neighbors, right? Here, here, and here, right? And we're gonna set them to the time plus 1, which is 3, right? So if you look at here, like the number 3 here, if 3 minus 2, right, is 1. So 1 is like the total number of minutes to make those yellow oranges become rotten, right? And after that, what do? We increment our time to 3, right? So now we start looking for number 3, right? Which is 1, 2, and 3 here, right? And we look at their neighbors only uh and we only process the fresh oranges, right? So which is only these 2 nodes in pink here, these 2 nodes in pink, right? So our second pass, we will look at 3, right? We just keep iterating down onto the next level, right? So and we set the value of these pink uh orange into time plus 1, right? Because it is the next level, so it is another minute for it to become rotten. So this become 4, right? So we reset our time. We increment our time, right? And now we look at 4, right? We iterating through the whole matrix and look for number 4, and which is here and here, right? And then well, we look at their neighbors and continue to make the fresh orange become brown, but they don't have any valid neighbors, right? The only thing we see is the 0 here, right? We're trying to look for number 1, right? Because 1 is the fresh orange, and they don't have any fresh orange as their neighbors, right? So we can add access and we can return 4 minus 2, right? I mean we minus 2 because we start from 2, right? So the total time it takes um to make all the orange being become rotten is 2 minutes, right? Because we only go 2 level deep, right? So like the red is level 0, right? The yellow is level 1, and then the pink is level 2, right? So it takes like 2 minutes. Okay. And then what happened if the node can what happened if it's impossible to make an orange become run, right? So after we exit the while loop, right, we cannot find any more neighbors, right? We just iterating through the matrix one more time and check if there any fresh orange. If there's any fresh orange, then we will return -1, right? So doing it this way save a lot of space. I think we can do it in constant space, I believe. Yeah, so we only have like one variable here. Uh, yeah, it would be constant space. And the time complexity would be O of m times n, right? Because even though we iterate like through the nested for loop many times, but we only process each node once, right? Okay, so let's look at a few constant here, and then column equal to with 0 of length, and then we want to start from we have the minutes, right? Let's start from 2. 2 is rotten node, so let's make a variable here. So rotten and then fresh is equal to 1 and 2. Or let me double check. Rotten is 2 and then fresh is 1. Yeah. So we will start from 2 and we return minutes minus 2 at the end, right? So we're gonna like do something, um, like do something, right? And after the while loop, we will iterate through to check if there's any fresh orange left, right? If there's any fresh orange left over, which means it is impossible to do it. So we can reach a -1. So if there's any fresh orange left, grid at row and column is equal to fresh, but it will return -1. Otherwise, we return the 10. Okay. So do something. What do we want to do? So we start from 2, right? And then we want to um, keep iterating, right? We can do a so we can do a breakfast search here, passing in the minute, right? And we have to increment our minute, right? So f equal to minute to time, right? So we can have a variable called like continue, right? It's for, and we can return the continue here. So this to be the condition to continue our while loop. So let's look at the picture again. What is the breaking condition? The breaking condition, right? When we look at number 4 here, what did we stop? We stopped because we cannot find any neighbors, right? Right. So that would be our breaking condition if we don't have any neighbors. So what do we want to do? Let's look at the picture again. So if we start from here, right? We want to find like all of the numbers that start with the time, right? With 2. And then we're gonna look at the neighbors at each of the node that start with number 2, and then set the value into time plus 1, right? And we increment our time and we keep going until we run out of the neighbors. Okay, so let's do that. We need a follow, right? This okay, and then we want to check if it is a um equal to the time, right? So if width of row or column equal to the time, right? Which is the one we are passing in here, right? So the first level, we got number 2, right? So we only process the node that start with the tab. Okay, what do we want to do? We want to look at their neighbors, right? So const neighbors equal to neighbors. It is a helper function that we will create shortly. And then if there's no if there's no neighbors, oh sorry, if there's neighbors of length, right? And then we want to set the continue Okay, yeah, sorry. Technical issue. So, yeah. So as I mentioned earlier, the breaking condition is when the continue is false, right? What does it mean when a continue is false? Which means we don't have any neighbors left, right? Remember, we look at number 4 here. There's no neighbors left, right? So we break the while loop and return. So same thing here. If there's still neighbor, and we set the continue to true, right? In that case, this will be true, right? And then we will increment our minute to 3 and then call the BFS again, right? Okay, so let's create a neighbors function. Get const neighbors, open row and then column. We will return row -1 column, and then row +1 column, and then row column -1, and then row column +1. We want to future, right? New row, new column. We want the row to be greater than or equal to 0. Then for the column, it has to be inbound, right? Less than 0. And set. What else do we want to check for? We only want to look at the neighbors that is a fresh orange, right? The grid of new row and new column has to be equal to fresh. And it is a little bit too long here, so I want to refactor a little bit this into an inbound function. Okay. Inbound equal to row and column. Right. And then this one equals column. Right. Okay, so we only want the neighbor that is inbound, valid neighbors, right? And we're only looking at the fresh orange. Okay. So what do we want to do? We want to iterate through the neighbors, right? What do we want to do with the neighbor? We want to set the values, right, of the we want to set the value at those neighbors to be time +1, right? Okay. Uh, I think that is it, right? Yeah, again, the breaking condition is when there's no neighbor left, right? We start from 2. So the first level is number 2. We look at all of the nodes that start with 2, and we set their neighbors into 3, right? And then we look at 3. If they're still neighbors, we set a continue to true, right? We return true here. Increments are minute to 3, right? So the next level we're looking at 3. We look at the neighbors of 3, and we set the neighbors of 3 to 4, so on and so forth, right? So at the end we have like the minutes here, right? -2 because we start from 2, which will be in the actual minutes here, right? And then because we start from 2, because the 0, 1, and 2 is already being used, right? So we don't want to use that. So we have to start from 2 plus 1, 3. And then after the while the preference search here, we're gonna look at the matrix one more time, and if there's any fresh value left, which means it is impossible uh to make all orange become run. So we return -1. So let's give it a try here. Accept it, submit, and it worked. Thank you for watching.